In this lesson, we're going to take a look at forms of common functions. The three function forms that we're going to take a look at first are linear, quadratic, and polynomial. Now, two of these you've had exposure to already, linear and quadratic. Polynomial may be a little new to you. What's interesting is these three actually are related to each other in a way. So let's take a look at these and talk about the common function form, examples of each, and the important characteristics. So we're going to start with linear. Most of you will remember common function form for linear is y equals mx plus b. So an example of that may be y equals 5/4 x minus 18. So we call that slope-intercept form. Well, another common form is what's called standard form, and it's written as ax plus by is equal to c. So an example of an equation that looks like that would be 5x plus 4y is equal to 6. Both of these are linear in form, even though they're written in a different form. They are both linear. So what is the important characteristic that makes something linear? Well, the important characteristic that makes something linear is that x, which is the independent variable, is of first order. What that simply means is in both of these equations, here and here, the x is just an x. It's not x squared, it's not x to the third or x to the fourth, or it's not the square root of x. It's just x. So when it is just x, we call it first order. Now, compare and contrast that with quadratic. The form of a quadratic that you're used to is y equals ax squared plus bx plus c. And an example of this might be y equals 5x squared minus 4x plus 2. You've worked with these before in Algebra 1. And what you learned then, that the important characteristic that makes something a quadratic is again that the x, the independent variable, is of second order. In other words, somewhere in the function there is an x squared. There can still be just an x term that has no exponent on it, but there has to be an x squared term, and we have that in here right there, the 5x squared. We say that's second order because we have an x that is being squared to second order. So that's a quadratic. And lastly, the polynomial. Now this form is going to look a little complex, but it shouldn't be too hard to understand. The common function form of a polynomial is y equals ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus plus dx plus e. Now that looks crazy and awkward, and what in the world is going on? All this is trying to say is that a polynomial is an equation that has an even higher order than a quadratic. It's a polynomial we're going to refer to as an equation that has an even greater than x squared term in it. So maybe y equals 5x to the fourth plus 3x to the third minus 2x squared plus 4x minus 8. because it goes all the way up to an x to the fourth, which is greater than a squared term, we would say that we would just call this a polynomial. Now, interestingly enough, linear and quadratic equations are both polynomials, but we're going to save the word polynomial for when it's greater than an order of 2. So important characteristic, the x, the independent variable, is of a higher order. In other words, greater than second order. So we could say third order or higher. The next two functions that we're going to take a look at are called rational and radical. Let's start with rational. So rational. The way we commonly understand a rational is a function form written like this: y equals p of x divided by q of x. Now, it doesn't give a lot of information. All it's saying is that y is equal to the ratio is nothing more than a fraction, something over something, the ratio of two polynomials. So for example, I could do y equals 3x squared plus 4x minus 5 all over 6x to the third plus 2x minus 8. Both the numerator and the denominator look like the polynomials from the previous slide. So a rational function is nothing more than one polynomial divided by the other. So, important characteristic of a rational function, it is the ratio of two polynomials. Now the next kind of function is called radical. Simply involves radicals, which we know to be roots. So the common function form, we'll write it as y equals a times the nth root of x minus h plus k. Now there's a lot of things happening in here. The only piece that we care about at this point is the fact that it has a root symbol in it. So an example of this might be y equals 4 to the third root of x plus 6 minus 9. So y equals 4 times the third root of x plus 6 minus 9. So the dead giveaway that it's a radical function is that it has a radical in it. It has the square root symbol, or a third root, or a fourth root, or a fifth root, so on and so forth. So the important characteristic here is it has a radical. Now actually I'm gonna adjust that a little bit, because a function can have a radical and it not be a radical equation. The key here is that the x variable is inside the radical. The x function is inside the radical. So for instance here, the x is underneath, it's inside the radical, therefore it's a radical equation. The last two function types that we're going to need to know, because we're using them the rest of the school year, is exponential and logarithmic. So let's take a look at exponential first. Common form of an exponential equation is y equals a times b to the x. Y equals a times b to the x. So an example of this would be y equals 5 times 6 to the x. Now the important characteristic that makes an equation an exponential equation is the fact that the x variable is an exponent. You'll notice that it's not a times b times x, it's a times b to the power of x. The x variable, the independent variable, is an exponent. It's in the exponent location. Therefore, it is an exponential equation. And lastly, we have what is called a logarithmic function. Now this one, you're not going to understand a whole lot until we learn to work with them later. All I want you to do is understand the form of it, and when you see it, to recognize it as a logarithmic function, even though you don't know how to work with it yet. Logarithmic function is y equals a times the log base b of x, and an example of that would be something to the effect of y equals 5 times the log base 4 of, over here it's supposed to be x plus h, x minus h plus k. So y equals 5 times the log base 4 of maybe x plus 3 minus 9, let's say. And the key pieces here is that we've got this thing in here that says log, L-O-G. If you see that anywhere in an equation, you automatically know that it's a logarithmic equation, specifically when the x is right next to the logarithm. So the important characteristic, the x variable is inside a logarithm. So those are the 7 major function types that we're going to be looking at in Algebra 2, and how to identify them, whether they're important characteristics, and some key examples.